All of them are awesome, perfect. You love them. Yeah. 10A. Ooh, second page. 10A. Give the domain of each function. Okay. So let's jump over to Desmos and get rid of normal distribution because you don't need that. So 10A. So f of x is the same thing as y equals. And then we have 2x divided by x plus 1. All right. So let's hit our home button. Big and home. All right. Ooh, look at that. Look at that pretty looking thing. So we want to find the domain of each. So the first thing we have to figure out is where this graph comes rolling along and then goes straight up, and then it comes almost straight up and then to the right. So what value would you think this line would be? What would this value be according to our x-axis? What do you think?
-1.
-1. So think about it. If I plug -1 in there, I get an undefined term because -1 plus 1 is 0. So my domain on this one will go from -infinity to -1 with parentheses on both, and then from -1 to infinity. Yeah. Oh, so go 2x and then divided by, and sometimes if this if on top it's a binomial or trinomial or something, put the whole thing in parentheses, and then when you hit divided by it, it'll make it a fraction.
Okay.
Is that okay?
Yeah.
So yeah, so -infinity to -1, and from -1 to infinity, parentheses on everything because we can't be equal to -1, and we can't get to the infinities because it's just like really hard. What else did you see?
Number 8.
Number 8. Did that answer your question? You good? Okay. Number 8.
Hi.
Well, hello. How you be?
Good.
Good. Number 8. Something. Did I get it? All right, I think I have attendance right now. All right. Remind me what number I'm doing. I'm sorry, I just forgot. 8. Thank you. Number 8. Solve the inequality. Okay, so let's just graph it. We're going to graph it just as exactly as it sits. So I'm going to get x divided by x squared minus 9. And then over here, we want less than or equal to 0. Ooh, so pretty. So, I would think if I go bigger and bigger, it's going to stay purple over there. So something to note. Do I have a solid line in there? I do. Okay, now let's kind of figure out why we don't have solid lines at the, I believe that would be about -3 and at +3. Why do you think they're not solid lines there? My inequality had less than or equal to, but why is it not a solid line? Solid line means it's included, right? Yeah.
Because if you plugged it in to x squared minus 9, that would be 0 and you can't have a 0 and you'll not be.
Correct, perfect, awesome. So if I plug this -3 in here, I get -3 squared, which is 9. 9 minus 9 is 0, that's undefined. And then also if I plug this 3 in over here, 3 squared minus 9 is also 0, so that's undefined. So in order to solve this situation, it's going to come from -infinity and get to -3, soft bracket on the -3, because I can't include it because that gives me an undefined term. But it's going to start back over again with a square bracket on the 0, because I can indeed put the 0 in. 0 gives me a 0 on top, gives me a -9 on bottom. 0 over -9 is 0. That works. So square bracket from 0 to parenthesis 3. Does that make sense? So Desmos does some good stuff that allows us to solve it. Again, we just have to utilize the kind of the knowledge we know. Okay? Yeah.
So what would be like our answer to that one?
It would look like this. You have to write it as interval notation. So it'd go -infinity to -3, and then square bracket 0 to 3. Oops. Okay, so those values there, if I plug any of those values in the region, I'm going to get a negative number. Okay, and we wanted less than 0. Less than 0 means it would exist below the x-axis. Okay, and the reason why we have rounded brackets here and here is those would be, if I were to plug those exact values into the denominator, it makes it a 0 on bottom, which is undefined.
Okay.
Does that make sense?
Yeah.
And then the infinities are always soft brackets. So at the hard bracket here, it's because that's a solid line, so that's going to be a hard bracket for you. Sometimes on Desmos, they might show this as a dotted line. So just kind of be aware of that. Dotted line also means you would deal with a parenthesis versus a square bracket. Any others that you saw on the homework that I can help you with? You feeling okay? Did you all realize to kind of ignore the -10 to +10 in the x and y, or the -5 to +5? That's just basically why they put that in, is when we used to teach this just using the graphing calculator, it made it easier to change your window so you could see what's happening. But being Desmos is so nice that we can go in and out on it. It's great. So nothing else to worry about, consider, have a hard time with? Okay. Can I switch pages? Feel good about this? Everyone's happy? All right. I'm just going to take a quick look, see what... Okay, so on... I didn't have to label any key points because you didn't ask me about any. All right. Is there anything here? Oh. Let me see. Oh, I think that's going to work. Look down at number 8 on graphing algebra number 2. Graphing algebra number 2. Down at number 8. See where I'm looking? And I'm just going to graph that to see what's going to happen. Because I think something different is going to happen. So because on top I have 2 terms, I want to make sure I put the top in parentheses, because I need to make it a fraction. Divided by, and then x squared plus x minus 30. And then I want it to be less than or equal to 0. All right. Anything else going on here? Okay. We're seeing everything that would take place where if I were to plug values in the purple region, it would give me a value that's negative or equal to 0. Okay, so let's focus on these. All right. So let's think about what this graph is doing. So this is basically saying soft bracket or parenthesis, -6 to hard bracket -2, square bracket, and then square bracket at 2 to 5. Okay, so why is the -6 a soft bracket and why is a 5 a soft bracket? What would happen in this equation if we had that? You got it?
When you plug them in,
Yeah, when you plug them in, the bottom of the fraction becomes a 0, which is undefined. Okay, so you are approaching it, but the reason why the -2 works is if I plug -2 on top, it's going to give me 0 on top, but if I plug -2 on bottom, it's going to give me a number. It's not going to be an undefined term, and the same thing with +2. So those are a few things to think about. All right, so we've talked about vertical asymptotes and horizontal asymptotes, correct? And I didn't go over the hardcore rules of it. Basically, the vertical asymptotes happen when you have a denominator that has a variable, a letter in it. But did you ever hear of a function that has a hole? Did you ever hear that term? You have a hole in a function? The hard thing with a hole in the function, it's kind of hard to realize, how do I have a hole? What does the hole really mean? So I'm gonna draw an equation that has a hole in it, and let's figure out how this might work. I'm going to go x squared minus 1 divided by x plus 1. Okay. This has a hole in our function. And if I'm looking at the graph, you're like, what is this hole you speak of? Because right now I can see where it crosses the x-axis and I can see where it crosses the y-axis. That's joyous. I'm happy. But, I mean, you would kind of think this graph, because it's x squared, like if I change one thing here, watch this. If I just change that from x plus 1 to x plus 2, look what happens to the graph. Okay, I didn't really make a major change. I just changed that. It goes from a straight-looking line to, if I did this, to a weird-looking, can't even call it a parabola. It's just a weird function. Okay, so let's figure out why this would be a hole. Well, what I want to do is I want to do this. What would the top of this fraction factor out to be? What would the top of my fraction factor out to be? X plus 1 and x minus 1. Good. Okay, this is called the difference of two squares. I'm sure you've heard that term at least once. Close parentheses, divided by x plus 1. Okay, so that's the exact same graph. Agree? So why am I saying there's a hole? What was the definition of the hole? What had to take place if a hole does exist? Yeah.
That's why.
Yeah. So the x plus 1s actually cancel each other out. Okay? So which in theory means we have a hole at -1. The reason I say -1 is x plus 1 equals 0, meaning that's the same factor top and bottom. X plus 1 equals 0. Subtract 1 from both sides, you get -1. So let's take a look here at -1 on Desmos. I'm going to do it one of two ways. If I go right here, try and get to -1. Ooh, there it is. What does it say? Undefined. So that's where a hole is. Now let's see what a hole actually looks like in Desmos. I'm going to center that best I can. And just keep zooming in on that -1. Seeing up at top where -1 is, recenter it. Okay. Not really seeing a hole yet, but let's zoom in on that as much as we can. Just curious if it's going to do anything goofy. There we go. There we go. You see that right there? That's not normal. Okay, that wasn't somebody, making some weird iteration on their drawing. That right there defines that there's a hole on this problem. Now, it doesn't necessarily show us the hole, but if I zoom in anywhere else on this line, I'm not going to get something strange like that. Okay? If I just kind of access, notice they have like little tick marks along this, going forever this way, and I'm zoomed in a lot. Okay, I don't even know what my -1 to, I don't even know where I'm at. Okay, what is this value here? This is saying this is all undefined here. Becomes a value there. Something's taking place. Come out here. Yeah, I'm so close to 1. Desmos doesn't know what to do. And when I get to here, oh my gosh, look at what's going on. So I'm zoomed on so much that I'm like so many decimals out of 0. But can we all agree that that looks a little bit obscure? I mean, if I go back to Desmos, that's all it looks like. And what we did is we had a microscope and just zoomed in on that -1. So things that you have to watch out for is if you graph something and it seems way too simple, like our original example was the x squared minus 1 over x plus 1, you know that because your graph comes out to a straight line, something happened. That straight line, the reason it's a straight line is that it's basically graphing the straight line of x minus 1, okay, as our straight line, because you are able to cancel out. So watch out for a hole. A hole takes place when you factor out the top and one of the binomial factors out of the bottom. Or if you were able to factor an x out on top and an x out on bottom and these cancel out, you're going to create a hole at 0. But a hole is something that definitely will take place. When I go back to that problem and look at it, it says label all key points. The intercepts, well, the intercepts are easy to get. This is an intercept and this is an intercept, x and y intercept. I don't have any asymptotes on here because a hole is different than an asymptote. An asymptote makes the graph shoot straight up or straight down the horizontal or vertical line that you're dealing with, or the slant asymptote we haven't really gone into great detail on. So, and then the max and the min for both of these, or for this graph right here, is our absolute max is infinity, our absolute min is negative infinity, because of how the graph looks. So, let's see. I don't think you're going to come across. Oh, go to number 12. Go to number 12, please. So this is probably the only spot where Desmos isn't going to work nicely for us. Okay? They tell us we have an equation of this and a slope of this. I think that slope equals 4/3 or slope is negative 4/3. That copy's not good. So let's just say they're saying the slope is equal to negative 4/3. I can't decipher what it means. So Desmos will not solve this for you. The ones that give you 2 points you can plug into your table, but this one doesn't. So then you have to remember your point slope formula. And I don't know how your teachers have done in the past, but realize this, x1, y1, so this is y minus 4 equals negative 4/3 x plus 3. This equation, so when you plug values into point slope, they become opposite signed. So that's why the positive 4 becomes a negative 4. That's why the negative 3 becomes a positive 3. So that equation is the answer. Now, unfortunately, in Algebra 1, and in middle school math, and in other math classes you might have taken, Your teacher was insistent upon you solving it for y. And I'm telling you now, don't worry about it. This answer here is the more accepted worldwide answer. This answer would be accepted on the IB exam, which is a worldwide curriculum. I taught IB for years. But, so why did we always keep solving for y? The reason we kept solving for y is that's how we were trying to get you ready for using the graphing calculator. But I can plug y minus 4 equals negative 4/3 x plus 3 into the calculator, and it's going to graph that straight line. Okay, that's the beauty of Desmos. You can plug it in any form. Okay, so my friends, feeling good? All right, so what do we say? We go ahead and do graphing review. I don't know how my hand is working faster than the processor here. Number two, come on. And we'll do all of them. Sound deal? Front and back? Cool, you have the period to work on that. If you have questions, come talk to me. If you have any old homework that I might have forgotten to put in for you, come let me know. Other than that, you got the rest of the period to hopefully get this done.